electrons are traveling in the materials and not the holes. On the N side, we have free electrons. And they can move around in the crystal. Yeah? But it's not that huge amount that we have with a metal conductor. Yeah? It's a very limited number. So that means that on the one hand, we have an N material, we have some free electrons here. And on the other side, we have a P material. We have some not saturated links between our silicon atoms. But for both sides, the base material is silicon. Yeah? It's silicon here, it's silicon here. Here we have implanted some boron or aluminium. Here we have implanted some phosphorus atoms. And the more we implant, the more P-conducting the material gets. And if you implant a huge number of atoms, phosphor atoms in here, then we call the semiconductor nearly metal, with nearly metal properties, because then you have a huge number of holes or a huge number of electrons. And it's getting more closer and closer to a metal conductor. Yeah? But normally we don't do this.
We have aluminium, for example.
On the left side, we use materials for the fifth group.
Yeah.
Because we have to have the free electrons.
Yeah.
So we have to use the fifth group. Here we have some holes. That's unsaturated links we have to use from the third group. Okay. Yeah.
Is it the real shape of the silicon?
The real shape, it's normally a wafer. Huh? So it's 200 micrometer thick. And there you have the structure. There you implant. Maybe do you do the implantation? So that's the wafer. We have an area, we implant some aluminium. So we have third. This is P conducting. And there we have an area, we implant some phosphorus. So that's the fifth element. Then we have an N conducting silicon here. Yeah. And the higher the energy, the deeper the atoms get into the wafer. Huh? But the problem is, the deeper you implant, the more you destroy the lattice structure.
The more you destroy what?
The lattice structure.
Physical state.
The lattice structure is how the atoms are arranged. Huh? There's this tetraeder with silicon or with iron, this cubic lattice structure. So in the old times, you do a vertical implementation structure, but now we have some lateral structures, because it's easier the manufacturing process. But nevertheless, we can think that we have a vertical structure, so there is an N area in close proximity to a P structure. And the properties of the semiconductors is not defined by this so-called bulk material, but the properties is defined by the area where the two materials meet. That's where our interesting properties
occurs.
Huh? So that's why I make a little bit bigger. There. Sponge here this time? No. So maybe you have a handkerchief also this time, or a paper.